Good morning, Year 10. This week's work is on congruence, just a continuation really of last week's work. Congruence, first of all then, what does it mean? Well, congruent shapes are shapes that essentially are identical to each other. They have the same size sides, they have the same size angles, but they could be rotated or reflected as long as they fit back onto each other. So I've got a selection of shapes here. Which shapes would be congruent to each other? Well, if I take shape E and rotated it, then it fits perfectly onto shape H. So you could say that one pair of congruent shapes here would be shapes E, and shape H would be a congruent pair. So that's the idea of congruence. Definition of congruence is they're exactly the same shape and size. The images of rotated and reflected shapes are congruent with the original shapes. The main higher GCSE question focuses on triangles and proving that triangles are congruent. In other words, that they are identical to each other. And you have 4 rules that you can use to allow you to prove that shapes are congruent. You have SAS, which represents side, angle, side. So if you had a triangle and you knew that both sides that were next to each other and the enclosed angle were the same, then that would be enough to be able to prove that 2 triangles were identical, congruent. Another example would be if you had angle, side, angle, side, angle. So this setup here, if you had 2 angles and the enclosed side, that would be enough to be able to prove. Also, you could have 3 sides. If you knew all 3 sides and the length of those, well, that would create congruent triangles, they'd be identical. And the last one that you can use to be able to prove that 2 triangles are congruent is this right angle hypotenuse side. So if you know 2 triangles that are both right angle triangles, you know the length of one of the sides and you know the length of the hypotenuse are the same, then they must also be congruent. These are the kind of questions that you get here. ABC is an equilateral triangle. D lies on BC and AD is perpendicular to BC. Prove that triangle ADC is congruent to triangle ADB. Okay, triangle ADC is this one here, A to D to C. Triangle ADB is this one over here. Well, they certainly look congruent. They certainly look like they're exactly the same size, but they've just been reflected in that line A to D. But that isn't enough just to say that. We have to use one of our four rules at the top here to be able to prove they're congruent. So this might be our starting point for this proof of congruency. The first thing is the 2 triangles share the same side, A to D. So A to D is equal to A to D. That's a shared side for both of these. And we have this idea that we've got one side ticked off. So we're maybe looking at the S we've got, but we need 3 facts to be able to prove our congruency. What else do we know here? Well, we're told that ABC is an equilateral triangle. So we're told in this case here that all of these 3 sides are the same as each other. So we've also got now that A to B is the same as A to C. A to B equals A to C. You have to say a reason, and that's because they are all sides of an equilateral triangle. And you've got now also, you've got another side as well. Now, that's actually the hypotenuse of the right angle, those sides, because you do know, and we're told that A to D to C is a right angle. A to D is perpendicular to B to C. That also means that this side here is also a right angle. So we can say that angles, we can say that angle A to D to C equals angle A to D to B, A to D to B, and they're both equal to 90 degrees. Okay. The reason we've got is that in the question AD is perpendicular to BC. AD, symbol for perpendicular is that one, to BC. That's my reason. So the proof that we can use here, which one of these congruency rules that we're going to use to state at the end, is that we've got a right angle, we've got a hypotenuse, and we've got another side. Right angle, hypotenuse, side, congruency. Okay, and that's the kind of idea, stating our three facts and then stating the rule that we've used to help us be able to get there. Another one. Okay, what about this one here? We're told that E is the midpoint of A to B. A to B and E is the midpoint. So straight away, I'm putting little dashes on here because A to E must be the same length as E to B. A to D is parallel. A to D is parallel to B to C. A to D is parallel to B to C. Okay. So those lines are parallel, put little arrows on there to demonstrate they're parallel. Prove that triangle AED, this triangle here on the left, is congruent to the triangle CEB. CEB is this one here. Okay, right, let's have a look at this one then. Well, I think the first fact that I'm going to use is that this angle in here and this angle in here are the same size as each other. We'll write this at the top here. Angle AED is equal to the angle CEB. And the reason behind that is because vertically opposite angles are equal. Okay, right, so that's one of our angle facts that we can use. Next, what else do we know? Well, we actually also know as well that these two sides, we said before, are the same length as each other, they're part of the triangle. So that A to E is equal to E to B, and that's because E is the midpoint of AB. So what we've got now in the setup, we've got an angle, we've got a side. Now one of our rules is angle, side, angle, so if we can find another angle that's the same, then we'd be okay. But we do need the angle when the side's enclosed, the angle that creates the side that we've just calculated between the two. We need to come up with a rule really to demonstrate that this angle here is the same size as this angle at the top here. And they are the same. We're going to use the fact that they're parallel lines here. And we've got that here at the transversal along the parallel lines means that these two angles are the same as each other. We have got that angle DAE is the same size as angle CBE. And the reason why they're the same is because the alternate angles in parallel lines are the same size. Alternate angles are equal. Now the rule that I've decided to use here of the four was that we've got this one here, an angle, this one was a side, and this one was another angle, and the side was enclosed between the two. So we use angle, side, angle, congruence. Okay, good. Let's just do one more. Right, what about this one on the bottom here then? We've got the ABCD A, B, C, D, at the bottom here, yep. And D, E, F, G are squares. We're asked to prove that triangle CDG, I'm going to have to draw that on here. C to D to G, this one up here, okay, is congruent to the triangle ADE. Okay, let's draw that in different colour. ADE. A to D to E. Okay. Right, those are the two triangles. Now we've got to try and prove they're congruent to each other. Right. Well, a couple of things, I guess. The first thing, if I'm looking at this triangle here, the red triangle, we've got this side on the red triangle, and we've got this side, A to D, on the black triangle, are the same size as each other, because they are sides of the same square. So that's maybe our starting point, first of all, that we've got that A to D on the black triangle is equal to C to D on the red triangle, and that's because they're the same sides of the square. Basically the small square. Maybe I should have written the small square there. Same size of the small square. But I think we can do something similar as well, which is this one here, that D to G is the same as D to E. So similar idea, exactly the same thing, but this time a big square. D to G is equal to D to E, and that's the same sides of the big square. Right, so I've kind of got A, D, E. I've got two sides. What we'd really like to be able to prove now is that the enclosed angles are the same as each other. And the enclosed angle for the ADE triangle is this one. And the enclosed angle for the red triangle, CDG, is this one in here. We want to come up with a way of being able to show that that pink angle and the green angle that we've just drawn there are identical. Well, I think they are identical because I think they're both made up of a right angle here and an extra little bit. And I would call that extra little bit, the bit angle ADG, the angle X. So I think we can both write down that the angle C to D to G is equal to 90 degrees plus X. And I think that also angle A to D to E, is also equal to 90 degrees plus that angle X. So therefore, angle CDG is equal to angle ADE. And we have now a side, and an enclosed angle. So this time our proof is side, angle, side, congruence. So that's the idea for all of these questions. This week's work, you've been given just 4 questions on a sheet that's attached to the VLE. Please can you answer those questions on paper, writing full solutions in a similar kind of context and manner as I've done here, writing down which proof you've used at the end as well. You take a photo of your answers and your solutions, and then can you upload them back onto the VLE so your teachers can mark them at the end of this week. Thank you very much. Have a good week.